Recording started. Okay. So friends, if you remember in the last class, I have discussed about this question, stock span problem. So did you all remember this question? I think it is already full screen, right? Somebody saying full screen. It's already full screen, no? Okay, right. So what this stock span problem says, friends? So let me quickly, revisit and then I'll start the new problem. Okay, and if you remember, when I discussed about this question, I have been told that, so if you know the solution, so 4 more questions you can easily solve. So today we are going to see those 4 questions. Okay. Okay. Right. Okay, so according to this question, so what is the span definition here? You take any particular day, from the day, see its left side, how many values are continuously less than or equal to that value. Along with that value, we need to add and we have to put it here. So that is the definition of a span. So we have already seen the n square solution. So I think some of the student had told this. So n square solution we see, but obviously it gives TLE error. So how we are going to optimize? So we have seen the stack based approach. So where I given homework as, so find out its time complexity, something like that I given order of n time. Okay. So in this problem, what we are trying to do, friends, whatever that is useful, basically we are deleting from the stack, and whatever it is useless, we are keeping inside a stack. So based on these 2 things only, next 4 problems are going to be there. Okay, now if you see the complete code to this question, so we have declared the span array and we have taken the stack also. First element will be 1, we know, because it's a starting day. And just to the remembering purpose, whenever if you complete any particular index value, we are going to keeping that index into the stack. Then since the first element is already over, now the story is starting from the second index, which means index number 1 onwards. Okay, so what I have checked, for example, if I found something that is useless, something that is useful, basically I'm going to delete that from the stack. See, I'm checking here. Okay, so st of stack of stack of. So from now onwards, what I'm going to do, friends, rather than writing this much, okay, so rather than writing this much, if you want to get the top of the stack element, you can simply write st of -1 in the Python. So you can write simply st of -1. This is index. Okay, so now since I want a value of the array, so let me write price of. Okay, right. So I'm going to write like this. I think here it is not st, it is price. It's a price, right? Okay, nice. Price of, topmost element of the stack I'm going to take and I'm comparing. So this code, I hope everyone understood, because in the last class I have explained this clearly. Okay, now let me take a new problem, that is, so nearest smaller element on the left side, friends. So in short, we are going to call this as nearest smaller element, NSE, to its left. Okay, so let me explain first by taking one example so that it will be more clear. So let me take, this is the input array and number of elements are equal to 8. Number of elements are equal to 8. Now how the output array looks like is, let me call output array as result. So this is the input. Input array will be given and number of elements are given to us. Okay, so see the left side. Okay, for any particular element you take, see its left side, find out the smallest element. If more than one smallest element is there, you need to take the nearest one in terms of a distance. Okay, so for the first element, so this element is 7. For the first element, there is nothing present on the left side. So I'm going to take its value as -1. Okay, now. Now, similarly for element 2, see its left side. So if you see its left side, okay, so we are having only one element, 7, but that 7 is not bigger, friends. So therefore, I am going to keep -1. Okay. Now, if you take this element 4, see its left side. See its left side. Okay. How many elements are there? Just give me 1 minute. I'll be back. Okay, so see its left side, how many elements that are present. Now, if you take this element, its left side, two elements are there. Out of that, one element is small. So straight away, I'm going to take that element. Similarly, if you take this element, okay, see its left side, two elements are present. Okay, so these two elements are smaller, right? One is 2 and another is 4. Both are smaller. But among these two, whichever is closest not in terms of a value, closest in terms of distance. So let me tell you, friends. So closest in terms of distance. Array indices. Okay. Now, if you take this element 6, this is just one step away to the 4. This is also smaller only, but this is 2 steps away. Therefore, who is smaller? Can you tell me now? 4 or 2? 4, right? Very good. So 4. Okay. Similarly, next, for the element 9, all these 4 values are smaller only. But who is the closest one? Who is the closest? Nearest? 6 is the nearest. Very good. So 6. Can you tell me for element 3, what is the answer? We have only one small element. So you can take that as the answer. Okay. For what about 8? What about 8? See its left side. Find out all smaller elements. Among that, which is near, you need to take. So that is 3. What about 11? In fact, to this 11, all these elements are smaller only, but closest one is 8 in terms of distance. Okay. So 8. Or you can call it as the first smallest element on the left also you can call. The first smallest elements also you can call. All right. Okay. For 8, why not 2? Okay. For 8, okay. Why not 2? You have 3, right? 3 is close, right? In terms of distance. 3 is just one step away to the 8. Whereas 2 is you need to cross this. Avinash, hope you got it. Array smaller only, but closest. Closest I am asking. Did you understood the question? Closest in terms of distance. Have you heard so far? Did you understood so far? Okay. Nice. Okay, let me take you one more example. Let me take you one more example. So the input array is, let's say, now see the output array result. So first, I can call the same problem as first smallest element to its left. Okay. Now see for every element left side we want. So for the first element, do you think anything present on the left side? Nothing, right? So therefore we are going to get its value as -1. First element. Now real story start from the second day. Okay, which means from here. Now see its left side. Do you get any smaller element? Any smaller than 3? No. Therefore -1. Now you take next element will be 4. See its left side. We are having 2 elements. Out of that, this is smaller. Therefore, try to take this as the answer. What about 8? See, this is also small. This is also small. This is also small. To its left side. But who is the first one that is coming? 4. Therefore, 4 as the answer. What about this element 2? I think no element is there, right? On its left side. Therefore, -1. What about element 9? I think all elements are small only, but who is closer to the 9? 2. Next, you take element 6. I think element 6 immediate closure will be 2. Yes. Next, element 1. Can you help me? What is the answer for this one? Nothing. So therefore -1. Okay. Everyone got it, friends? Everyone got it? Okay. Nice. Now, will you able to try the brute force solution order of n square? Will you try brute force? Because because it's very easy. I'm skipping. Yeah. So brute force you can do and you will get order of n square time. Order of n square time. Please everyone try that. Okay. You have to take two loops like how we have done the previous question. This one. Where it is like this. You take I1, J, I minus 1. Like that, you please do it. But now let me explain the best solution, that is order of n solution using stacks. Okay, so the always story will be very simple. So you take a stack and you need to find out what you need to put in the stack and what you should not supposed to put. Okay, but before that, we should know what exactly I want. You take any element, let's say array of I. You take any element, friends. For that element, we need to find out what is the smallest element, its left side, right? Now, see its left side, whatever that array of I, all elements to its left side, we want. First of all, let's see all elements that are left side of I. That are left side of array of I. See all the elements that are left side of I. Among all that elements, we need to find out the minimum element. We want to find out the closest minimum or first minimum, I would say. Among all those, first minimum I want to find out. Okay. That is what my question is. Now, in the stack, what you should keep, what you should delete, that you should know, which means in the stack, we should know what to keep, what not to keep, what not to keep. If you know this, story was over. Okay, if you know these two, the story was over, friends. Useful, useless, yes. Useful, useless, simple, like the previous question only. But before that, let me complete its code. Okay, I'll first starting formalities are there now. Let me complete those starting formalities. So let me take function. This is nearest smaller element to its left. So input array given to us along with number of elements also given. Hope you can convert this code into Python. So I'm writing in a general language. So array will be given. So you need to create a result array. Result array you need to create. After that, so without thinking anything, result of 0, can I put -1 without having any second thought? Tell me, friends. Because for the first element, nothing is present. So obviously, okay, -1 you can keep. Very good. Next. Okay, let me declare one stack also. Let me declare one stack also initially. Okay, so stack. Right. Now, inside stack, push 0. Yes, because first day was over. Very good. Now, real story start from first day onwards. Okay, which means I is equal to 1 onwards, the story will start. I less than n, I plus plus. Okay. Right. So once it is done. Okay. I think so far everyone understood what I'm trying to do here. So far everyone understood, friends, what I'm trying to do. Okay. See, somebody is saying st.push is equal to array of 0. No. Inside a stack, I am pushing the indices. See, let me tell you one thing, friends. Let me tell you one thing. If you see same question in the YouTube, I think multiple people have said lot of solutions. I don't know why they are ultimately confusing you people. If anybody trying to learn this solution from the YouTube now, they will hell a lot of videos will be present and everything is a confusion. Somebody will tell that push a index. Somebody will say that push array of value. Lot of confusion. Forget about all this. Just to be with me, let me tell you, these 4 problems are going to be so simple. You will feel itna easy hai kya? Trust me, I will make that. Okay, just to be with me. Be with me. Okay, forget about all that YouTube nonsense, whatever is. See now. Okay, so because see, this day was completed, very good. So I will put that day into my stack, into the stack, because I should remember, okay, that day is completed, very good. Now okay, now friends, I should know what to put inside a stack, what not to put, right? Okay, you people only just give a try, and tell me what to keep, what not to keep. Useful data, useless data. In this problem, earlier problem, if you see, okay, let me go back to the stock span problem. Let me go back to the stock span problem. Yeah. So here, what is useful data? Useful data means what they're asking in the question. What they're asking in the question, see all the values to its left side that are smaller than or equal to. That is what we want. But we are not keeping that value inside a stack. Basically, we are deleting that any value that is greater than which I don't want. But that value I am keeping in the stack. So that what will happen next time, those comparisons will not happen. Getting a okay? So that is the story in this problem, stock span problem. Whereas in this question, if you see now, in this question, if you see, what is useful data, what to keep means useful data. Okay, useful data. Useful data, let me tell you, any element to its left side, smallest value that I want. Everyone agree? Any element, its left side, first smallest, not all smallest value. First smallest I want. Okay, see now, see what is the standard code that is present here. While first I should stack should not be empty because I need to delete. Let me tell you what to delete. Okay, st dot, I think length of st should be greater than 0, which means stack should not be empty, and okay. Now I am going to write some condition, friends. See here. So always the story will be, listen carefully, friends. Always the story will be, you check array of I. Currently your I is at here because first day was completed. So currently I is at here. So compare array of I versus topmost element that is present in the stack. What is the topmost element that is present in the stack? 7. Not 7, index of the 7 that is present here. Okay, na? Now, let me check. What to keep now? Small value you keep. Small value, which we require, that we will keep. It's left, we'll keep. So therefore, now try to check, friends. Now try to check. Let me show you in a green color. So this is stack st, right? Now st of -1. When you write st of -1, top of the element that we will be getting. But top of the element is index. I want value. Therefore, you need to keep like this. You need to keep like this. ARR. ARR. Whatever this value, for example, is bigger than the array of I, then in such case, can you tell me, is it useful or useless? Useless. Useless, right? Very good. This is useless. So pop it. Useless, na? So pop. Same condition, I'm going to write it here. ARR of ST of equal to also you can take, friends. Assume duplicates are not there. For example, in the question, if they're given duplicates, now, then if they're asking strictly small, if they ask strictly smaller, then you can include equal to symbol also. That is up to you. Depends on the text cases. Okay. Now, ARR of ST of -1. This is greater than, which means bigger. I want small, but I'm getting bigger. Then I will delete from the stack. So here for the time being, I am assuming that duplicates are not there. All values are distinct. In such case, there is no point of duplicate, right? So ARR of I, right? Then what I will do, I'll simply pop that element from the stack. Pop. Once this is done, now it's very easy, friends. Simply you check if st dot length of st is greater than 0. For example, if that value would have been bigger, then result of I is equal to array. Result of I is equal to ARR of st of -1. Always top of the stack will contain your answer. But friends, top of the stack containing index, I want value. Therefore, I have written ARR. Generally, st of -1 will give you topmost element, but that is index. I want value. So I have written ARR. Once it is done, else if that is empty now, if that is empty, if you remember in the stock span, what we have kept here, I+1 we have kept, right? If you remember, I+1 we have kept there. But here we have to keep -1. That's it. Over. Solution is over. Over, friends. Now you might be thinking, Arey, how? Let me do the dry run. Let me do the dry run of this code so that it will be more clear. Okay. This code I will take to the next slide. Now let me do the dry run here. Okay. So finally you can return that. Finally you can return the I think result array. Finally you can return the result array. Okay. Okay, friends. One thing we have forgot. Right, that what. So once the story was over, we need to push, right? So that that day was completed. So that we should not supposed to forget. So push index I. So that, okay, that is completed. That is important. Okay. Okay, good. Now, thanks for reminding. Now, let me take this input array. Let me take this input array. I'll show the dry run. Okay, so yeah. Now see carefully, friends. So this is the result array. So this is the result array. Okay. Why storing index X when we need an elements? Yeah, Akash, just wait, Akshay, you'll get the solution. See, you can store elements also, you can store indices also. There is no problem. These unnecessary YouTube guys, those who had half of knowledge, these YouTube fellows are there. They have half of knowledge and they are putting content in the YouTube without proper study, proper research. They'll solve some 100, 200 questions in the DSA lead code. They'll call 5-star lead code, 3-star hacker, 2-star hacker rank, and they'll put some videos on that, just making students fools. That's okay. Just to make the student fools only. Okay. See, if you're designing one approach, see here the main thing is stack, friends. Here main thing is stack. You should understand the stack. That principle called as LIFO. That's it. For one problem you are using pushing index, one problem you are keeping value. What is the point? What is the point for having multiple solutions? They'll make videos and they'll do this, that, they'll do some promotion. So that and all the unnecessary headache that is. Okay. See here. See the concept, friends. This is now. See the initial setup. What is the initial setup? Declare a result array. Okay, I have declared. So size of n is equal to 8. Next, result of 0 is equal to -1. Very good. Okay, because nothing left present on the left. Okay. Empty stack I have created. Very good. Then let me push the first day so that, okay, this is completed. Now let me start the story from the second element onwards. Okay. Now what I have told to this element, left side, if anything is bigger, delete from the stack, because I don't want that. I don't want. So you take any array of I. Okay. Its left side is greater than the array of I, which means bigger than the array of I. You simply delete from the stack because that is useless. Okay. Now length of the, remember when you are deleting, make sure that stack should not be empty. Okay. Length of the stack is greater than 0. Of course, one element is there. Let me check. When you write this statement, you will get the topmost element of the stack. Okay. Now check. Topmost element of index is 0. Is it bigger? 7 compared to 3? Yes, it is bigger. So you delete that value from the stack. Okay, I have deleted. Very good. This loop will continue as long as these both conditions are true. Now let me check. Next time, length of the stack is greater than 0. No, this time it is equal to 0. Since it is logical AND operator, so this loop will fail. Loop will fail. Okay. Now let me check. is my length is greater than 0, then take topmost element. Stack is empty, right? So then in the result of I, let me simply keep -1. Okay. So if you think normally also, 3 left side, nothing is present, which is smaller than 3. Therefore, you will get -1. Okay. Once this is over, before I goes to here, you please push this value to the stack so that it will remember, which means index value 1 will be pushed to the stack. So next time I will be coming here. Okay. Again, same story. You compare its immediate left element. That is what we need. Array of I, it left side. Okay. Now if I check, now listen carefully. This element is smaller, which means I want it. So don't delete from the stack. Now you check while length is greater than 0. True. That is true. Array of topmost element, is it bigger? This I am not comparing 1. Array of 1 I am comparing. If you see here, yes, that is not bigger. Therefore, while loop will fail. Whenever while loop will fail, control comes here. Is empty a stack is not empty. Then output will be whatever this index of that element, which means ARR of ST of -1, which is 3. So normally also 3 should supposed to come. Okay. Before incrementing this I, you push the index to the stack. Okay. Let me push it index to the stack. Now I will be at here. Now again, same story. Compare the topmost element. Right. What I want, 8 left side, all smaller element. Among that first one I want. Now if you check this element, is it bigger than 8? Bigger means you delete it. But 4 is not bigger, right? Therefore, this loop will fail. Okay. Now check. If stack is empty, no, stack is not empty. Then take the topmost element and you put it here. What is the topmost element? 4. You put it here. In fact, result also I want 4 only. Hope you are getting the friends. And here the beauty of the stack is whichever you inserted last inserted element will be coming out first. In this problem also, what I required to its left side closest one that I want. The left side closest smallest element will be in the top of the stack. That is the reason we are using stack and we are getting the solution. Not because of putting the indices or putting the values in the stack. You should understand this point, friends. Stack is working based on the LIFO principle, which means recently entered element. If it is close, I want. Yes, 8 is recent, immediate left is 4. 4 is small. So I'm getting the answer. Where is the 4? Top of the stack. That is the beauty you should understand. Here, the beauty is not you are keeping the value or not you are keeping the index. The beauty is stack designed principle, LFO. Okay. If I go to immediate next value, you put this index so that I will remember, okay, this is done. Right. Now, you see, friends, now. What is the immediate top element? That is array of 3, 8. 8 bigger? Yes, I don't want it. Delete it. While condition true. So let me delete. Okay. Next, what is the next smallest? 4. 4 is bigger than 2. Yes. So not required. Delete it. Okay. See the beauty. Next, if it is saying comparing with this one. Okay. Again, this is bigger. You delete it. If it is a brute force approach, definitely it will compare with 7 also. But the beauty of the stack is it is skipping this element 7 comparison. Why? 8 is already bigger than 7. So here itself, the 7 story was over. Then again, value coming. So it is not checking. Right. Okay. Now, once if the while loop fails, stack is empty, I thought you can put -1. Yes, put -1. Okay. Before I moving here, let me put index number 4 here. Okay. Now you check this, friends. Now you check this. Okay. 9. You see all the elements that are smaller than 9. Generally in brute force, what we will do? First, we will compare with these two. Okay. Smaller. Then we will generally stop it. But okay. Now you compare with this small. So you put this value here. Before I goes here, I'll put it index. Next. This element you compare with this. This is bigger, right? Bigger means I don't want. Delete it. Okay. Next. Element 2. Element 2, in fact, smaller, right? So this while condition fails. So whatever this element, that we will put it here. Before I increment this I need to put this value into the stack. So this is not there. 6. Now let me check. Immediate left. 6. So smaller, 6 is no, right? Then delete from the stack. After that, it is comparing with 4. 2 is smaller than 1. No. So delete. After that, it is skipping all these comparisons. That is the beauty in the stack. If it is a brute force, every element will be compared. We are in a hope that I may get a value that is less than 1, but you won't get it. Once the stack is empty, keep -1. In fact, this is the array which we required also. You compare this array. You compare this array with that array. See, are we getting the correct answer or not? Try to compare these two and tell me, friends, we got right answer or wrong answer. Correct answer, right? Sahi hai na? Very good. Hope you understand what is the idea that is working. Okay, very good. Now, 3 more problems are there. If you did not understand, that's okay. We have 3 more questions. In your lifelong, you won't forget. In fact, you won't even by heart also. In fact, you won't even by heart also. Okay. Next question. Again, I will use the same kind of input to the next question also. This time I will write. Previously, we have seen nearest smaller element left we have seen. Now I will explain nearest smaller element, its right I will explain. So nearest smaller element on its right. Okay. So same input I am taking, friends. So let me write the output array. Okay. Now check this. So this is the result array. Somebody is saying stack is also similar to a brute force approach. That we are deleting unwanted items in this stack comparison. Yes, very good, Iron. Yes. Ultimately, in brute force approach, we are getting n square time complexity because of unnecessary comparisons. Those unnecessary comparisons we are avoiding using a stack. That is the idea. Yes, that is true. Now see, friends, next question. This time, for every element, its right side I want. Therefore, without having second thought, can I keep here answer as -1? Tell me. Of course, to this element, nothing will be present in its right side. So you will get -1. Every element, its right side. Whenever it's right side, now I'll come from right to left. Okay. Things will become easy. That's it. This element, right side, only one element that is smaller. In fact, if you see this question, I think all you will get mine. Okay, no. This element, its right side, smaller is 1. Okay. Now, element 9, its right side. 2 are there. Among this, which is the correct answer? Tell me. 6 or 1? Who is closer? Close means close. Who is closer? Yes, 6 is closer. For 2, right side, smaller. Only one element. In fact, that only smaller. So 1. What about 8? I think immediate close is there. Yes. What about 4? I think 2. What about 3? I think 2. What about 7? I think 3. Okay. So if you remember, this time I am filling from right to left. If you remember, right to left I am filling, friends. So again, the initial setup will be same. Let me copy paste this code. Let me copy and I'll paste the code here because the initial setup will be same. Nearest smaller element to its right. To its right side. Okay. Result array I have taken. Very good. Rather than writing result of 0, I should write n-1. Everyone agree? Everyone agree, friends? Loop reverse hoga. Yes, that is true. -1. Taking a stack. Inside stack, what I should push? Tell me. What I have to push? Very good. n-1. Because last day was completed, right? Okay. Whichever day is completed, that you need to push to the stack. So I'll take a stack here. Okay. This I have already kept -1. Very good. Now the story will start from here. Okay. This let me push index into the stack. Very good. So this is stack st. Okay. Now the story starts from 6. For 8, if it is 6 means n-2. Right. So now the story will start from I is equal to n-2 onwards. n-2. I greater than or equal to 0 and I will be decremented. Okay. Now I will remove this everything. Let me from the fresh I will write. Okay. Now again simple, friends. What I need, that I will push to the stack. What I don't need, I will delete from the stack. Okay, na? See now, always the comparison will be Now if you take array of I, this time it's right side, friends. Right side, array of I, right side element bigger than I don't need. I will delete it. So I will delete it. Okay. Can you tell me for any array of I, its immediate right side element, where it will be present? In the stack, right? Everyone agree? Any array of I, its right side element will be present in the stack ना, मतलब compare करने के लिए. So generally we will compare with array of I, right? Array of I versus its right side element. That right side तो कहाँ मिलेगा? Stack में मिलेगा. Which means condition is st of -1. This is index, but I want array element. Okay, this value is bigger than array of I. So what I'm going to do? I'm going to delete it. Simple. So I'll write the same thing there. Okay, I'll write the same thing. While, but before I need to check length of the stack should be bigger, and ARR of st of -1 is bigger than array of I, which means that is useless. So I will delete st.pop. Once it is done, once this while loop was over, okay, maybe I'll put the bracket so that no confusion. Then it is simple, friends. If length of st is greater than 0, then result of I is equal to ARR of st of -1, right? Else, what should I write? Result of I, if stack is empty. What should I keep, friends? At the end, if stack is empty, -1. Over stories. Okay, one important thing, we need to push that index. Or every time I'm forgetting, and you people are reminding me, thank you for that. Push that value to the stack. That is the story, friends. For this, simply, okay, they are creating lot of headache in the YouTube. Like I was just going through some solutions, right? Because see, this I came to know in my second or third batch itself, which is I think 24 or 25 months back, which is almost 2 years back, when I'm explaining same solution to the students. I think this is very long back. Okay, couple of students told that, sir, in some of the YouTube video they told that they put the indices, some of the videos they put the value, but why you are putting that indices only? But then I was surprised. I don't know why any confusion here. I was just went through some of the random YouTube videos. Like there I came to know that kiske paas whatever solution that fellow, right? One test case definitely it will fail. In the down that some comments will be there. Your code is not accepted here. Your code is not accepted here and there. Like then I after seeing those solutions, I forget my solution, which I about to explain to the students. Literally, then I thought, I am wrong or they are wrong. I was confused. Then after some time, then I forget. Sub chhod do. Okay, whatever I know that I want to explain to the students. So this much, friends. What you see here? What is there to by heart here? What is there to by heart? What you require, that you put to the stack. What you don't require, delete from the stack. Delete from the stack. See, you can put in value also, no problem. Then comparison with value. Getting? But that value, if you keep, does it work for stock span problem? Tell me. Ion, you can put the value, but that does it work for stock span problem? No. तो बच्चों कंफ्यूज हो जाएगा ना, इनमें इंडेक्स डालना पड़ता है, वैल्यू डालना पड़ता है. इंडेक्स इज अ जनरल वैल्यू. Index is a general thing. Using index, you can get value, but using value, will you get index? पूरा array ढूंढना पड़ता है. पूरा array ढूंढना पड़ता है. वैल्यू, ओके, ये वैल्यू कहाँ मिले, कौन सा इंडेक्स में मिलेगा. मैं इंडेक्स दे दिया तो ना ऑर्डर ऑफ वन में हो जाएगा. That is the array random access. So general concept you need to learn always. Okay. So 2 problems are over. Let me explain the third problem. That is, okay. That is nearest. So first question is nearest smaller element on left. Na? So this time the next problem will be nearest. This time will take greater. First we will talk about its left. Nearest greater element on its left. Okay, nearest greater element on its left. So far we have seen small on the left, we have seen small on the right, we have seen. Let me see the greater. Nothing, friends. Simply sign will change. That's it. Nothing will happen. Sign will change. That's it. Okay. Let me take this code. Again, please don't by heart. Please don't by heart. Think this is the new problem and try to solve. बहुत लोग क्या होता है ना by heart करके जाते हैं इंटरव्यू में कुछ something different they will ask, right? But don't forget, don't at all even remember also. Even I also don't remember. I will remove everything and I will start from the scratch. Okay. First, let me take an example and I'll explain with that. It will be more clear. So I'll take the result array. So result array. Okay, now see friends, without having second thought, happily I will put -1 here. Yes, of course you can keep because nothing present on its left side. Whether it is greater, whether it is smaller, kuch nahi hai left mein. So you can keep -1 and you put this index here. Now the story will start from the second day. Okay, now you should know. See, what I want, that is most important. See, you take any array of I, see its left side, What I want, friends, I want greater element, na? Correct? The question is about greater. But left side, any smaller element comes. Any smaller element comes. I don't need. So I will pop it. I will pop it. Okay. Where will you find the smaller? Where will you find its right side element? In the stack, right? Stack में मिलेगा ना हमको. So st of -1 ARR, whatever the element present on its left side will be available in the stack. If that is small, which means less than, compared to array of I don't require. So I will delete it from the stack. So what will happen, friends? Nothing will happen here. Okay, again, I will start. It's as a new problem only. So this is the initial setup. Okay, very good. You have done the initial setup. Start the story. While length of st should be greater than 0 and ARR of st of -1 is small compared to array of I don't want. I want a bigger element. So therefore, I will pop it. st dot pop. Okay. Now, if length of the stack is bigger, then result of I is equal to ARR of st of -1. Else, result of I is equal to -1. And you put st dot push I. Over stories. What is the difficulty here? Nothing. That's it, friends. Got it? Any doubts? Anyone having? Were you liking this approach? Tell me. Are you people liking this? My main thing is, friends, don't buy heart. Don't buy heart. Don't see any YouTube there and all. Okay. I on linking. Acha, liking. Okay, sorry. Okay. Somebody is asking if length of ST greater than 0, repeat it. This is, if stack is not empty, then your value will be present on the top of the stack. Otherwise, this is -1. See, if you want to understand this 100%, I think you must visit that stock span problem, friends. Because I started the story at the stock span problem. Right? So please listen to that and you will get it. Understand better. Okay. Now, I think next question. Fourth question is what? Nearest greater element on its right. On its right. Okay. This will be now cakewalk, I think. Will you try? Will you try? Will you try, friends? So result array. I'll just fill this array and you can try. N is equal to 8. Ion, please wait for a minute. I'll take your doubt. So right side, nothing. So you can put its value to -1 and start the story from here. Right side greater I want. So I want nearest greater element on right. Okay. 6 right side, nothing. So -1. 9 right side, nothing. -1. 2 right side, 9 and 6 are bigger, but 9 is closer. 8 right side, I think 9 is bigger. 4 right side, 8 is bigger. 3 right side, 4 is bigger. 7 right side, 8 is bigger. So this is the output, friends. So please work out. Okay. Okay. Now, so we have seen initially stock span problem I have explained. Stock span problem. And then so using that stock span problem, 4 problems we have seen, friends. That is nearest smaller element to its left, we have seen. Nearest smaller element to its right, we have seen. Then we have seen nearest greater element to its left, we have seen. Right. So these were the 4 questions based on more or less similar pattern. Similar pattern. Okay. So I would request everyone, you take your own example. Please don't see the notes. Anyhow, I'll be sharing these notes with you. But without looking these notes, you first take your own example. Then please try to write the code on the OJ. I think these problems might have already given to you. Now, if they didn't give these exact problems, they might give you modification of this. They might give you the modification of these 4 problems. Okay. So please try to solve all these 4. Now, then there should be no confusion at all. Okay. They can ask any variations for this. So you should not having any confusion here. Okay. Right. Yeah. So now, Ion, yes. Now you can unmute and ask the query.
Sir, I have a little query that why we are taking the answer of first element as -1 and pushing index 0 or n -1 depending upon the we begin from left or right. Even we
So that
don't
is
do that, even we don't do that, our code should work fine.
what you are saying. Hmm.
Don't do don't do these 2 tasks here first.
Acha, yeah. Without that also it will work. Yes. But just flow, I am continuing that flow, right? In that flow, so I am putting.
Okay, I just asked you because it might be relevant for some other kind of problem when you told me that pushing an element does work here, but it doesn't work for the next span or the stock span problems. So I thought
Yeah,
it
that is
can.
also a reason. That is also true. But
Uh, okay.
tell me.
But I don't think in stack span or next greater or smaller, this should be this have any relevance. Pushing result
Yeah.
0 as -1 and pushing 0th index in the stack.
Okay, just see one thing here. For example, if you didn't put this value and if you didn't push, if you straight away start from the 0, you are saying our code will work. That is what you are trying to say?
Yes, sir.
So always this comparison will fail, right then?
No, sir. Because while have two conditions. When the first condition fails,
Wait. This will become false. I will be starting from the 0. Okay, yeah, this will work. Yes.
on
This is
any
also
kind
the-
of problem,
uh,
then okay, sir.
But yeah, I'm just writing. Yeah, without also it will work, friends. Yes. Okay. Yeah. So next greater product question was asked in Saturday evaluation. How to do two-sided comparison? No, not required to do two-sided comparisons. Break down that problem and into any one of these, you will get to know. Acha, left side, right side, they are asking. Huh? I don't know exact what that question is. Okay, then create two arrays. Write one code which will find for left, write another code which will find for right. Two arrays will be there and you multiply. Two separate arrays you need to create. Yeah, rainwater. Tomorrow I'm going to discuss, friends. So three more questions were left. One is largest area histogram, one question. And this rain trap, you need to trap the water. That problem also there. And order of one time, you need to find the get minimum. That question also there. So these are the good questions. So that I'll discuss. Maybe today time might not sufficient because I have one more question I want to discuss. This question, valid stack sequence. I'll discuss this. Tomorrow's class, I'll discuss that definitely. I mean, day after tomorrow. So did you remember this question, valid stack sequence? Right. So I'm going to give some stack permutations. Based on that, you need to tell whether it's yes or no. So let me say the push order is. So I am trying to push elements in this order. 1, 2, 3, 4, 5. So one of the stack permutation, let me give. One of the stack permutation. Three, 1, 2, 4, let's say 5, 4. Tell me what is the output, true or false? Invalid or valid? Yeah, whatever. Yes, straight away you can say invalid. Because you see, how you are going to solve this question, friends? So maybe this they will give as an input array, output array. Two arrays basically they will call. I don't know here as a push and pop they are calling. So this is the push array. Whatever the array that they have given, this let me call the push array. This is the order in which we need to push. And this is the pop array. Okay, so 0, 1, 2, 3, 4. So 0, 1, 2, 3, 4. Okay. This is the push array and pop array. So let me take the first element, 0th index. Now, okay, so I'm going to take this element. See carefully, friends. Okay, first we need to, does it matching, 1 is matching with this 3? No. So you need to push all the elements as long as this element is matches with any one of these. Okay, now I'll check this and this. Are they are matching? No. Then I will push it. Next, are they are matching? No. Let me push this. Are they are matching? Yes. Okay, so I'll push. Now, whenever if this is matched, I can pop it. Very good. Let me pop. Next they are asking 1. Now I'm going to check. Does 1 and 2, are they are matching? No, they are not matching. Then I'll stop and I'll say that it is not possible. It is not possible. But for example, let's say here if 2 is present and 1 is present here, just for the sake, let me take 2 and let me take 1 here. Okay. Now, so as long as this matching, so I'm keep on pushing. I am keep on pushing, friends. Right? Okay. Now the next element will be 2. Right? Does on the top of the stack, are they are matching? Are they are matching? Yes, matching. Then pop it. Next, are they are matching? Are they are matching? Yes. Then pop it. Whenever you are popping, make sure that check stack should not be empty. Whenever you are doing pop, make sure that stack should not be empty. Okay, so next, is there any element to check here? Nothing. Then basically I'm going to use two loops, friends. So one for loop will be corresponding to array index. So something like I is equal to 0, I less than n. So I plus plus. Okay. So first inside a stack, let me push index I. Okay, array of I. In this question, push the array of I, because you are comparing element, right? Then let me take one while loop. While loop. In the while loop, what two things should I need to check? One is stack should not be empty. So length of the stack should be greater than 0. Length of the stack should be greater than 0. Now again, I'll start from the beginning. Just I'll explain this code and I'll write the code here. Okay. For the first time, I will put this element here. Very good. Okay. First element I is at here. So I have pushed that element. Now I'm going to compare. Does this element is matching with the top of that element? No. So here, for example, if I use, listen carefully, friends. So length of the stack should be greater than 0, and I need to compare top of the element of the stack, which means, so stack low anyhow inside a stack, you are pushing that element. Therefore, to get the topmost element of a stack, you can directly compare st of -1. If let's say, see, I should know what to push when, I mean, should I put that element or should I delete it? These two things only you should know. Okay. If that element, this element is matching, this element, that element is matching, then should I put that element? I want to delete it. Tell me, top of the stack element, array of this element, if they are matching, should I push or should I delete it? I have to delete it. Simple, right? I need to remove. So I am going to compare top of the stack, for example. Okay, this is the push array 1. Okay, stack also they need, for example, here if 1 is present, you have to pop it. So is matching with, now here, listen carefully, friends. So if I write arr of I, does it work? If I write arr of I, if I write st dot pop, does it work? You might be thinking for the first case it might work, but later it will not work, friends, because I is corresponding to going like this. I is going like this. I is going like that. So then what should do in that case? In such case, what we have to do? Can anyone tell me? Can anyone unmute and tell me? Two pointer. Okay, take a new pointer.
So take I is equal to 0.
Take j is equal to 0. Okay, very good. Where shall I take here?
No,
Where?
sorry. After
Okay.
a for loop.
After this for loop.
Yeah.
Okay. What I should write inside j? 0, na? I here.
Yes, sir. 0. 0, sir.
0 or I? What I should write?
I, sir. Sorry. I is standard 0 also.
Okay.
You
Let me
should
write.
write.
Let me write I. Okay. So here I'll be comparing with j. I'll pop it. Is it enough?
No, sir. Also is comparing in while loop. J is less than N.
You need to write one more condition, huh?
Yeah.
Okay, just a minute. So one more condition is j should be less than I.
No, sir. N.
J should be less than n. Okay. Then we have to increment j value. Huh?
Yes, sir.
Okay. Is it work? Does it work? See here, if you see carefully, here first expected element will be 3. So which means all these 3 elements I should suppose to push into the stack. 1 you have to push until you get 3. 2 also you have to push. 3 also you have to push. Then
So
I
J,
will get here. So then you need to check these 3 elements, right? In such case, if you write, it won't work now.
J has started is 0.
0. Okay, very good. Now does it work?
Yes.
Yeah, tell me friends, does it work? Somebody saying no. Okay. Still students are saying no. Okay, Ayush, can you tell me what is the correct approach?
Sir, J is in outside the outsider loop. Put
Outside
J.
this for loop, huh?
Yes, sir.
Okay. Does it work now?
Yes, sir.
Okay. Can anyone tell me, friends, does it work? Anyone else says it might fail? Okay, so let me in fact do the dry run. Okay, now check here. So initially, J value will be pointing at 0. Okay, I value will be 0. J value will be pointing at 0. Both initially, both will be at 0, 0. Now, first this element I will push it. I will push this element. Okay. Now I'm going to compare. Does this element is matching with the top of the stack element or not? No, it is not matching. Then this while loop will fail. Again, I'm going to increment the I value. Now I'm going to push this element. Now let me check. Does it matches with the top of the stack element? No. Then again I will increment. Okay. Now I will push this. Now see, does this element matches with the top of the stack? Yes. Whenever there is a match, I told you to pop. Okay, so this element I have popped off. Okay, then increment the j because the next element I need to compare. Now, does this element is how long this while loop will be true? As long as both conditions, 3 conditions are true. Okay, does this matches with the top of the stack? Yes, then again pop it. Again pop it. Okay, next increment the j. Now check, does this matches with the top of the stack? Yes, it matches. Then again pop this element. Okay, and increment the j value. J value. Okay, now check carefully, friends. Okay, does this first of all does stack is empty? No, then this while loop itself will fail. Okay, now next time where is your I value will be I plus plus, right? So now currently I value will be at here. So 4, I'm going to push it, right? Then let me check. Length is S, stack is not empty, and the top of that element is matching. No, it is not matching. Not matching. Then this while loop will fail. Okay, so I will increment the I value and I will push this value to the stack. Okay. Now currently J value is at here. Here. Let me compare. Is there any match? Yes, matching. So I will pop it. And I'll increment the J value. Okay. Now is it matching? Yes, matching. And I'll increment the J value. Okay. Now I'm checking, is length of the stack is not empty? Is greater than 0? No, this while loop will fail. After that, I'll increment the I value. Okay. Out of the array. So this loop also will fail. So at the end, if everything is properly done, then stack should compulsory become empty. So if length of the ST is equal to 0, then which means return true or whatever you write, return true. Return true. Else return false. Very simple. See, whenever remember friends, in your solving the stack questions, now you should know what to push, what to delete. That's it. If you know that, then things will become very easy. Just a minute, I'll put the charting. Yeah, got it, everyone? Okay, good. So friends, today I'm going to stop it here. So in the next class, I'm going to discuss some few more. I think 3 questions are pending in the stack that I will discuss it in the next class. Okay. Yeah. Somebody saying, sir, you are popping inside a while loop, whereas I would push inside a while loop. Yeah, depends. Anything you can do, not an issue. We just check whether it is working for remaining test cases also or not. Then accordingly, it will. Okay. Yes. So I've done from my and friends. So I think Albin had something to say. Right. Okay. Now you please, I will add these notes to the LMS, but you know, please solve on your own. Okay. So yeah, Albin, yes.
Yeah,
Want
I
to-
just want to release the DLC quiz. I'll release it now.
Okay. So are you going to share the in the Slack chat, Zoom chat?
Yeah, I'll share it in the Zoom chat. Just a second.
Okay. Okay. So shall I stop recording, right? Like,
Yeah, you can.